Hello, student. So we are going to do this question. So I hope this is a very important result we are going to derive. Okay. So that is we are going to prove that the sine signal is a periodic signal, and the period is let's say the period is t. It is equal to 2 pi by omega naught. So this is what we are going to derive or prove. So so already know that uh, we we already know that the sinusoidal signal is a periodic signal, but this time we are going to prove it using the using the condition of a periodic signal. So what is the condition? So already you know that the condition, that is, if we have a signal xt, okay, so it will get the same result, same value or same amplitude after some time. Okay, so this time is called the period. Okay, time is called the period. So if in a signal will get the same value, that means same amplitude after a certain time, so that time is called t. So we call it the periodic signal. So this is the condition for periodicity. Okay. So we are going to use this condition for our derivation. So, so, so in our case, our signal is yt. Our signal is denoted as yt. So this yt may be a voltage signal or current signal or power signal, any signal, we don't know. Okay. So, so in our case, our yt should be equal to the same signal after t time. Okay, so yt should be equal to yt plus t. Okay, so this is the condition for our signal in our case. Okay, so if we substitute this t and write it again, so we will get this kind of expression. So we have a sine omega naught t, that is yt. Okay. So it is equal to, now instead of t, we have to substitute t plus t. Okay. We have to substitute t plus t instead of this t. So it will be equal to sine omega naught. Now here we have to write t plus t. Instead of t, we have to substitute t plus t because it is after t time. Okay. So you can see that. So this is equation. So you can remove this a. So we will get sine omega naught t is equal to sine. If I expand this, so I will get omega t plus omega naught t. Correct? Okay. So how we can prove that this is a periodic signal? So if we can find the value for this t, okay, if we can find the value for this t which satisfy this equation, then we can say that, so this t is available and the equation is satisfied, and so that means we can say that this is a periodic signal. If t is not there, if we couldn't find the value for t, that we couldn't that this equation uh, satisfied, then we can say that this it is not a periodic signal. You get it? If we can find the value for t, if we have a value for t, okay, that satisfy this condition, that satisfy this equation or this condition. Okay, equation. Then we can say that it is a periodic signal. Periodic signal. If we don't have a value for t, if we don't have a value for t, okay, if t don't have a value for t that satisfy this equation or satisfy this condition, satisfy this condition. If we don't have a value that satisfy this condition, we can say that it is not periodic. Okay, so finally we have to find a value for this t that satisfy this equation. Okay, so so if we go back to our explanation of a sine and cosine signals, okay, I explain it using a circle. No, I explain it using a circle. That is the basic idea of a sine wave. Okay, and if this is a diameter, and if this is another diameter for this circle, okay, we know that if there is a point like this and it is moving around this circle like this, okay, and we have learned that 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 participle projection to this diameter, let's say it is a y diameter or some, so project of this projection of this participle is this diameter, we get a sinosodial signal. Okay, uh, so you can see that if this circle is going from here to, so I think you can remember it if you have seen my seen this session. Okay, so if the participle is moving from here to here, okay, from moving here to here, okay, this projection, this point is moving like this, okay, like this, it is moving from here to here. Okay, so you can say that projection, you can see that the projection of this participle is this. Okay, this projection of this participle or of this point on this axis is like this. Okay, so it is moving from here to here, the projection is moving from here to here, no? And this distance or this value is the sine value we get. Okay, so you can see that when this participle is going to from here to here, the write it again. Okay, so I will write it again. So if the participle is moving from here to here, okay, so our projection will move here, okay, from here to here, and the participle is moving from here to here, our projection is moving here to here, and the participle is moving here to here, the projection is going to minus direction, and the participle is going from here to here, the projection is going to this direction. Okay, and after one circle, the point is here again at the starting point. Okay, so now already it has traveling to 5 radians angle, no? Because it's travel from here to here, 5 by 2, another 5 by 2, another 5 by 2, and another 5 by 2. So we have altogether that participle is traveling to 5 angle. Okay, so if it is again traveling another circle, another round from here to here, so we will get the same result. No? After 2, 5, we will get the same result. Okay, then if we get another round, we will get the same result. Okay? So if you say that if you so this is one time, Okay, so if it is going 2 times, that is 4 5 angles, and three. If it is going another time, it is 6 5 angles. Okay, like this. Okay. So if it is going 1 round or 2 round or 3 round, again we will repeat in the value. No? Okay, so that is actually periodic. Okay, that is actually periodicity of what of the signal. Okay, so you can see that if this number of round is n, okay, you can see that after 2 5 n, okay, after 2 5 n, you will get the same result. Okay, so for sine signal, we can say we can we can we can write like this: sine theta. Okay, so any theta, that theta may be here. Okay, so it is maybe here. This may be a theta. Okay, this may be a theta. Okay, so if this now it is in this location, that theta can be any value. Okay, it is a it is not a constant. Okay, it is a variable. So this theta can be any value. Okay, so you can see that if this participle is going 1 round from here to here, okay, I will use another color. This participle is going another one circle from here to here like this. It is 2 5. It is 2 5 radians, no, 2 5 angle. Okay, so you can see that again we will get the same value. So sine theta is actually this direction. Okay, this distance, that is the sine theta. No, you already know that sine theta is this length divided by this length. Okay, that is the sine theta. So you can see that after traveling 2 5, you will get the same value here. Okay, and if it is going another round, again you will get the same value. Okay, so we can see that sine theta is equal to sine theta plus 2 5. Okay, 2 5, actually it is not 2 5, it may be a 4 5 6 5 8 5, anything, no? Because it is going round and round here. So you can see that 2 5 n. So we can write that sine theta is equal to sine theta plus 2 5 n. Okay, I hope you understand it. Okay, so if you couldn't understand this point, you can ask me, then I can explain it again. Okay, so 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 you can see that. Okay, so you can see that this n can be any integer value. It can be 1, it can be 2, it can be 3, it can be 4, any value. Okay, up to infinity. Okay, so if it is 1 round, it is 2 5. If it is 2 round, it is 4 5. If it is 3 round, it is 6 5. Okay, so it can be any value. So you can see that sine theta is equal to sine theta plus 2 5 n. Okay, so please compare this equation with this equation. It is it is look like the same equation, no? So here it is omega naught t is here. Instead of omega naught t, here the theta is there, and here you have the same theta omega naught t, and there are some value. Okay, so you can see that. Okay, so using this condition, we can write sine omega naught t is equal to sine omega naught t plus 2 5 n. Isn't it? We can write this like this. Okay, so what is our original signal? Our original expression, that is sine omega t is equal to sine omega naught t plus sorry, omega t, omega naught t actually. Okay, omega naught t, because we get this as omega naught. Okay, so if you compare these two, you can, this should be capital T, I'm sorry, this should be capital T. omega naught t. This is our original value, no? This one. Okay. So you can see that this is omega naught t. So you can see that these two terms are identical, no? So we can see that the t value can be there. Okay, so if omega naught t is equal to 2 pi n, okay, this condition is satisfied, no? So we can find the t value. From this we can find the t value. So this condition is satisfied, no? This condition is satisfied. So we can say that it is a periodic signal. So what is the value for t? Okay, so we can see that t is equal to 2 pi n. Okay, but when you are calculating the period, you have to get the minimum value that repeat in the same sample. So what is the minimum value? Minimum value is n is equal to 1. The minimum value we get at when the n is equal to 1. So we will get, so this is omega naught, okay? So we get omega naught t is equal to 2 pi. So we can see that t is equal to pi by omega naught. Okay, so it is proved. Okay, so this is very important result. You have to use this in use this several times for our calculation and analysis. Okay, so you have to keep remember this one, and it is better to have idea how to derive this, because sometimes uh, this type of question can come to your exam. Okay. Okay, so you can see that if we write the sine signal, if we draw the sine signal, it is like this. No, it is like this. Okay, so actually this is the t. No, this is the t. This is the t value, and it is equal to omega naught by 2 pi. Okay. So actually you can understand this this result. Okay, it is additional things. Okay, so you can understand this result using this circle. Okay, the basic circle. uh, I will write it here again because now it is not clear, no? We have many lines. Okay, so you can see that uh, I will draw this line now only. Okay, so you can see that if this circle is moving from through this circle, from this circle, uh, this this projection is the sine value, no? That is the sine value. Okay, so you can see that uh, so you can see that uh, this t, this t, okay, this t is a time to travel one circle, no? Time to travel one circle. After traveling the circle, it is repeating, no? Again, after traveling the circle, it is repeating. So this t is the uh, time taken to travel this point uh, one circle. Okay, so you can see that within capital T, okay, the this point is moving one circle, the complete circle. That means 2 5 radians, no? He is traveling 2 5 radians. So uh, from T time, it is traveling 2 5 radians. Okay, and what is the radian traveling for? What is the angle traveling for 1 second? That is 2 5 by T. Okay, so this is the angle for per 1 second. This is the angle per 1 second. You know that meter per 1 second is the velocity. Okay, so angle per 1 second is a, so this is a linear velocity, meter per second. So this is angle per second. So it is a angular velocity. Angular velocity. So this angular velocity is actually the omega, no? So also we call this angular frequency. Okay, angular frequency. So omega, so we can say that omega, so this is actually equal to omega naught, so 2 pi by t. So what is t? T is equal to 2 pi by omega naught. Okay. So same result, no? Same result. I hope you got the idea. Okay. And anyway, you have to do your assignment. Okay. So you have to prove that cos omega naught t is a sinusoidal signal using the same method. So I hope you can do this by yourself and try to do this by yourself as exercise. Okay.